we're talking about properties of rational exponents and radicals, and we want to simplify the following expressions. Assume all variables are positive. And so we're taking the square root of x to the 2/3. So another way that we can rewrite the square root is we can rewrite that as an exponent. And so we can write this as x to the 2/3, and then we can have the 1/2 written out there as an exponent. If we have a power raised to a power outside, what we can do is just multiply the exponents together, and then we get x. 2 times 1 is 2, and 3 times 2 is 6. And so that reduces to x to the 1/3, and that is the simplest form. Next example we have y to the negative 4 raised to the 2/5 power. Anytime that we have a variable that is raised to the negative, what we can do is we can move it to the denominator. But what we want to do first is we want to do this multiplication. So y, we multiply a fraction. Negative 4 times 2 is negative 8 over 5. And then in order to get rid of the negative value, what we can do is we can rewrite this as move it to the denominator. So y to the 8/5. And now what we can do is we can split this up a little bit, because what we don't like to have is we don't like to have a radical in the denominator, which right now we do because the 5 is in the denominator. So we can rewrite this as 1 over y. So we took 5 of those away because this is y to the 5 over 5. So what we have left is y to the 3/5. So in order to make this y whole again, or to get rid of that exponent, what we need 2 more. So what we want to do is multiply the numerator and the denominator by y to the 2/5. And what that will end up doing is it will make our denominator whole, because we can add those together in the denominator. Again, this is equal to 1, so it's not going to change what the value is. And so in the numerator, we multiply across, and we get that is equal to, just multiply across, and what we get is y to the 2/5. And in the denominator, y to the 3/5 plus y to the 2/5, we can add those together, and what we get is y squared. When we add y to the first plus y to the first, and then we get, that becomes y squared because we add them together. Next one, in order to add those together, we need to make sure that we have like terms. And so first thing that we can do to see what happens is we can distribute our 3 here. So when we distribute, what we do is we're going to multiply the exponents together. So 4 x to the 3 over 3, and then y, 5 times 3 is 15, and then minus. We can do the same thing with the 1/2. So minus, that becomes x to the 2 over 2, and y to the 30 over 2. All right. And then we can simplify the our exponents here because we can reduce these fractions. And so we get 4 to the x, or 4 times x, y to the 15th minus 2 divided by 2 is just x, and 30 divided by 2 is y to the 15th. Again, we understand that our coefficient out front is 1, and then we have x times y to the 15th and x times y to the 15th. Those are like terms, so now we can combine these, and what we get is 3xy to the 15th. Next one that we come to is we're just trying to simplify that radical as much as we can. We're trying to take as many things out as we can. So it's the 5th root of let's get rid of this. It's the 5th root of 4 times a to the 8th, b to the 14th, and c to the 5th. And so in order to take things out of the radical, we have to get 5 of those things. If we get 5 sets, or if we get 5 in a set, then we can take it out of the radical. So we're still going to keep the radical, but we want to try to rewrite what's under the radical to show that we can take it out. So the 4, we could rewrite it as 2 squared, and that will only give us 2, so we can't really get that in a spot where we can pull it out. So we can just write it as 4. A to the 8th. 8 is a little bit bigger than 5, so we can write a to the 5th, and then what would be left? So we have 5 of them here, and then that's going to be a to the 3rd. B to the 14th, that's 5 twice with some left over. So b to the 5th and b to the 5th. So 5 plus 5 is 10, so we have 4 left over. B to the 4th. And c to the 5th is just c to the 5th. Now, what can we take out of the radical? In order to take it out of the radical, we need to have 5 of them. So here we have 5 a's. So we can take that out of the radical. Here we have 5 b's. We take that out of the radical. Again, we have 5 b's. We only have 4 b's here, so that doesn't quite get us enough to get out of the radical, so we have to leave it in. And then we have c to the 5th. That has to come out of the radical. And so that's what we're going to be left with. So what comes out of the radical? A to the 5th comes out, and so we're left with just a. B to the 5th comes out, so we write the b down. Now, that was b to the 5th. That was this one. We have one more, so now we have to say b squared, and then we can take 1c out. And so we take 1c out, and that just leaves c. Now what's left under the radical is going to be the 4 is still under the radical, the a cubed is still under the radical, and b to the 4th is still under the radical. And so this is in our simplest form.